In lesson 10.2, we're going to be talking about the volumes of cylinders and prisms. One of the most important things to remember about volumes is that volumes are always measured in cubic units. For example, we could say inches cubed, feet cubed, meters cubed. So keep that in mind when we talk about volumes. To find the volume of a prism, it's fairly simple. You just multiply the area of a base and the height, or oftentimes people just think about base times height times width. So in this particular example, I would go 7 times 3 times 4, and this being the length and the width and the height to find my total volume. And when I multiply all those things together, in this particular example, I have 7 times 3, which is 21, times 4, which is 84, and my units are in inches, so it would be inches cubed. Notice how the label is cubed and not the number. And what they're talking about when they say the area of the base, what they mean is this 7 times 3, length and width, that's considered your base area, because we'll be talking about that again. And in this particular figure, here would be my base area, which would give me the 21, and then again times the height. And although you can't see it here because it's covered perspectively, this would be the base. Highlighted in green, I went a little bit over, but you kind of get the idea. Base times height times width, or I should say length times height times width, and the length times the width is considered the area of the base. In the second slide, the reason that we talk about this idea of the area of the base times the height is because it continues for any kind of prism. This is not a rectangular prism in this example. It's a triangular prism because the bases are triangles. But if you look at the area of the base again, so here being my base, which is a triangle, and I find the area of this triangle, I know that when I talk about volumes, in the previous one we said length times width times height, but really it's always the area of the base times the height. So when I look at that, one of the ways that they like to abbreviate that in our books and notes and that kind of stuff is capital B for the area of the base times H. And that highlighted red area that we saw before, that's what we write down as the area of the base. So in this particular example, I know that if I'm going to be using this formula, that the area of my base, which is capital B, is actually the area of the triangle that's the base, which is its base of the triangle, that is, times the height of the triangle divided by 2. 3 times 4 divided by 2 is the area of the highlighted red triangle. And then I multiply by the height of the prism, which is perpendicular to the base. In this case, happens to be 7. And so when I simplify this, 3 times 4 is 12, divided by 2 is 6, and then I multiply that by the 7. Or in other words, my answer is 42, and my label was inches, so my volume would be inches cubed. So the most important thing, I guess, that I'm trying to communicate here in this particular example is this area of the base idea. The area of the base is whatever you know to be the base in the prism, find that area, and then generally speaking, the other number that they give you is the height of that prism and multiply by that. In this case, the area of our triangle was 6, and then the height of the prism was 7, so I take 6 times 7, and that's how I get 42 inches cubed. In cylinders, we do the same thing again, believe it or not. We take the area of the base and multiply it by the height of the cylinder. And when I look at that, I have my volume, I have my volume as a formula equals capital B, which we know to be the area of our base, which in this case is a circle, times our height of the cylinder. And since we know that in this particular case our base is a circle, I know that that means I have pi times r squared for the area of the base, and then I multiply that by the height. And in our particular cylinder here, our radius is 3, so I have pi times 3 squared times the height of the cylinder, which is 7. And when I multiply all of this out, I have pi, which is 3, times 3 squared, which is 9, that's about 27. And then 27 times 7 comes to roughly 197.82, which you can see down below from my calculations. And again, our label is in inches, so that would be in inches cubed. And the thing I want to point out in here is what I've been talking about for the last couple slides, and that is that when we talk about this idea that the volume of prisms and cylinders has the area of the base, which we are labeling capital B, in our particular example here, since our base is a circle, really what we're doing is we're finding the area of the circle, which happened to be pi r squared, which, since we know that our radius is 3, is pi times 3 squared. So don't forget that the volume of prisms and cylinders is the area of the base times the height of that prism or cylinder. Let's take a look at another example. In the previous example, if you look right back there again, we notice that this prism is what we call a right prism because the altitude or the height of the prism is perpendicular to the base, and it's inside, or I guess you could also say along the edge. But in our next slide, what you notice is that we have an oblique cylinder, and in this oblique cylinder, our height is outside. Now the great thing is it doesn't even matter. We still have that our volume is going to be equal to the area of the base times the height. And in this particular example, we know that that means that our volume is pi times the radius squared, because our base is a circle, times the height of this cylinder, which is called h. And this particular example, again, we have pi times 3 squared times 7. And that's because we know that this capital B means area of the base. We know our base is a circle, and so we know its area is pi r squared. And since our radius is 3, that's pi times 3 squared. And we end up with the exact same answer as we did in the last slide, because even though this cylinder is oblique, the height of the cylinder is still 7, and the circle's radius is still 3. So the volume is still the same. In our last example, we're going to be talking about a prism that has trapezoids for bases. Again, our formula does not vary. We still have the volume equals the area of the base, which we represent with capital B, times the height of the prism. The difference is now, how do I find the area of one of these bases? So if I look into my prism here, and I notice that this prism is the one that's outlined in purple, and I want to find the area of this thing, the formula for the area of a trapezoid was base 1 plus base 2, add those two things together, times the height of the trapezoid, not the prism, and then chop that in half. And in our particular example here, just looking at that trapezoid outlined in purple, base 1 was 5, base 2 was 3, put that in parentheses, the height of the trapezoid itself was 4, and then divide everything by 2. So 5 plus 3 is 8, 8 times 4 is 32, and 32 divided by 2 is 16, so the area of that trapezoid was 16. This number now becomes the area of the base. And then, going back to my formula, I know I take the area of the base of that trapezoid, and then just multiply by the height of the prism, which happens to be 7. And so then when I multiply those two things together, I get a grand total of 112. And since my measurement was in inches, once again, it's inches cubed. The big idea here, again, is that we are talking about the area of a base, which we know to be the trapezoid. And so you find the area of that base, which we found to be 16, and then multiply by the height of the prism. So in this whole lesson today, 10.2, the big idea is that when you find the volumes of cylinders or prisms, it's always the area of the base times the height of the prism. And the base will either be a polygon or a circle.